Good afternoon, everybody. It's Wednesday, April 17th, and we had class today. And I told you that there's an activity I really like, but I think the complicated sets are complicated sets. The data sets are a little complicated as an introduction to linear regression, but it's still some cool stuff. So I want to just show you. I made this link available in this in-class materials block right here. And the movie data set is what I'm going to refer to this in the video. So feel free to play around with that data set yourself. Any changes you make isn't recorded on mine, so you really can just play around. So this is the data set once you open that up. And what it is every movie, I think this goes up to 217, every movie that came out in those times. So you might recognize this is Rocky, the original Rocky movie that came out November 21st, 1976. It had a budget of $1 million. See that money sign M stands for in millions of dollars. Domestic gross means the money it made in the United States. Worldwide gross means the money it made worldwide in all countries. And then, so you might recognize some of these other ones like Taxi Driver, Blue Valentine. Um, and as you go down that list, there's definitely movies you'll recognize. And what correlation does is looks at the linear relationship between quantitative variables. So I'm just going to show you the function you would do to look at that. You'd go to stat regression, simple linear is what we're going to use for now. And notice it has you choose which variables. So when you choose the X, remember you're basically choosing the explanatory variable. So let's just choose one. Notice that, I was going to say it wouldn't show the variables that weren't quantitative, but it actually does. But I'm going to say, let's just talk about the year it came out and its budget. So maybe we're curious about how this has worked over time, about funding for movies maybe has changed. It's going to have these other options. You don't need to worry about any of that stuff. Just go straight to compute. And you may notice there's a lot of information in this. Let me zoom in a little bit so we can break this apart. And also notice that it says the one of two. If you click this arrow, it's actually really nice. It automatically gives you a scatter plot of the data with the line of best fit drawn in there. And so notice that if you hover over that line, it should give you the equation, y equals negative 1478.7912 plus 0.7558 times x. Back to that first thing. So really what this says is we chose the dependent variable, and I know that our reading set doesn't use this language, but you can call that the explanatory variable, and the response variable is the year. And actually, yes, I said that the opposite. The independent variable is associated with the explanatory, so we set year as the explanatory, budget as the response. And then you'll notice that year is the one. And even though it says the word year here, you can imagine the variable X being written there. So you can substitute anything as in. It gives you the correlation coefficient. That's a 0.21175,243. So that's definitely in the positive in weak category. And if you look at this graph, you can see why. You can see that in general, as years have passed, movie budgets have gone up, but it's not super predictable. In general, there are many more movies that are made now than were made back in 1940. So you just see a lot more data. There's cheaply made movies, there are expensive movies. We see movies with budgets far beyond anything that used to exist. But there's kind of what this says is the year is not a good predictor of budget. As in, if I told you the year and that was all you had to make a guess for the budget, the guess wouldn't be very good. So again, looking at that correlation coefficient, that's really tells us right away that this is not a strong linear correlation. It's about 21% correlated. Let's change. By the way, you can always hit options if you don't want to start from scratch, edit, and you can just do things like change one setting in here. Like I'm going to say, I'm actually going to jump right to the strongest correlation. But if you want, if you look at these variables, take a second to think about what do you think is the strongest relationship between any two of these variables. Pause the video if you want to think about it. Just going to count down from 4. and then I'll get into it. So it turns out that the strongest relationship in this is the relationship between domestic gross and worldwide gross. Let's look at that. So in this case, you can jump straight to the correlation coefficient. Notice that says 0.93514,969. That's about 93.5% correlated, as in very, very correlated. If we look at the graph, we can see why. See how that data is really stacked pretty well in a straight line. A lot of this is kind of baked in anyway. If a movie makes money in the United States, it's already made that money in worldwide. So in other words, if a movie makes $100 million in the US, it's already made $100 million worldwide. So there's a certain amount of that that's baked in. But then you can see the regression does a pretty good job. So what this says is if you use this equation that's hovering up, and I said, tell me what the worldwide gross will be if a movie made $600 million in the United States. Well, we can see visually that that looks going over to that, looks like about 1,500. That would be $1.5 billion. Approximately, but you could also plug in for X. You could plug 600 in for X, and that would give you the exact calculation back. So that would be the strongest relationship we have in this table. Those are very well related. As in, if you spend a lot of money on a movie, you'll probably make more money, but it's no guarantee. So that would be the relationship between budget and either of the grosses. But definitely the strongest relationship is within these two. So anyway, there's a ton more to explore with this. I urge you to open this up, find your favorite movie in this list, as long as it cost $1 million to make. It should be here. I'd remove the movies that cost less than $1 million because there's so much variability than that. Then we really couldn't see as many patterns as we can see here. So let me know what you did and have fun with it. Play around. But I also just wanted to show you how you do those things in StatCrunch. It's all stat, regression, simple linear right there. All right, everybody. Have a good day. I will see you next week.